Hi everyone. It is Thursday, so hang in there. Yesterday we looked at how to balance one of these redox reaction. I don't know if I don't remember if I told you this, but these reactions are under acidic conditions. All right. So today our lesson is going to be what happened if these reactions are under basic condition. Now, there's a little extra step that you will have to do for that, but let's take this question up. Okay, question 6. So the first thing we did was divide these into two half reaction. So let's do that quickly. So we will divide IO3 to become I2 and HSO3 becoming SO4. So here's my half reaction. All right, so what am I going to do now? Well, if you remember from what we learned yesterday, the first thing we should do is to make sure that all entity other than oxygen and hydrogen are balanced. So for the red side, we want to make sure that iodine was balanced by putting 2 in front of iodate. See? Now we will worry about those oxygen and hydrogen. Oxygen first. So we can see that there's 6 oxygen. So to make sure that there's 6 oxygen on the right side, we add water. Just like what I'm going to do right here. So I2 plus 6 water. Because there's 6 oxygen on the left. Make sure there's 6 oxygen on the right. But by doing that, you add some hydrogen. So you're going to have to insert some hydrogen on the left to balance hydrogen out. So in total, there's 12 hydrogen. So what are we going to do? Well, add 12 hydrogen ions. That's what we're going to do. There we go. Now, this is, I guess, the hardest part, in my opinion. Balancing these redox reaction is the determination of electrons. Okay, or charge. The overall charge, I'm sorry. So, let's take a look at the overall charge on the left side. There's 12 pluses here. And of course, there are 2 minuses here. Okay, in case you don't know, there's 12 of these plus, and there's 2 of these minus. So 12 plus negative 2, that's negative, that's positive 10. Okay. Oh, the right side looks great because I2 has no charge. 6 water has 6, nothing is 6. This is nothing. So there's nothing. So no charge on the right side. 10 plus charge on the left side. To make them equal, remember we can only add electrons, and electrons are negative. We will add 10 electrons on the left to balance this thing out. So let's just rewrite this. So we're going to add 10 electrons to the left side to give me this half reaction looking like this. Very nice. Now we're ready to do the blue side. So for the blue side, looks like sulfur is great. No need to balance sulfur. Let's look at oxygen. Well, there's 3 oxygen on the left and 4 oxygen on the right. That's simple. We'll add 1 water to the left. Now oxygen looks great. Hydrogen doesn't though. There's 2, 1, 3 hydrogen on the left. So I better make sure there's 3 hydrogen on the right. Plus 3 hydrogen on the right. So, charge time. Overall, there's -1 charge on the left. And overall, there is +1 on the right. To make sure that the 2 charge are equal, we're going to add 2 electrons to the right to make sure that they're both -1. So that's what we're going to do. Add 2 electrons to the right side. Okay, so we're done with the 2 half equation. Now we're just going to have to put them together. But before we put them together, we have to make sure that the electron is the same number for both red and blue. Now, remember how to do that? That's right, lowest common multiple. So there's 10 electrons on the red line. There's 2 electrons on the blue line. I guess 2 and 10 is 10. To turn 2 to 10, we times 5. You're going to multiply 5 to everyone. There you go. You want to make sure this and this is the same number so they can cross out. Because right now we're ready to combine the 2 reactions. Let's combine the 2 reactions. There we go. We're done. Well, wait, not yet. Hey, look, you can actually cross out certain things in this reaction. Do you see water? Look at water. There's 5 water here. There's 6 water here. We can just take this whole thing out. 6 minus 5 is 1, so we take out the 6. Do you see anything else? Yeah, I see it too. Hydrogen. There's 12 hydrogen here and 15 hydrogen here. Well, goodbye 12 hydrogen. Goodbye 15, and you're left with 3. Anything else? Nope, I don't see anything. So, rewriting this, just to make it look neat, the final answer, of course, is 2 iodate plus 5 bisulfite will give you iodine gas, 5 sulfate, and 3 hydrogen ion. Now that is how you balance a redox reaction under acidic condition. Now, one of the things that you might want to do is check to see if you're right. Okay, to check, just make sure that what's on the left equals to what's on the right. All right, so I guess I can leave that with you. I'm sure you guys are capable of doing that on your own. Oh, look, I forgot about water here on the right. Yeah. Anyway, let's look at what we're going to learn today. Okay? So, yesterday we learned how to balance that equation under acidic condition. But what happened if you don't have an acidic condition? What happened if you have a basic condition? So, the title today here is Basic Condition in Redox Reaction. How would it differ? Well, let's start off with a question. So I have right here manganate. I have this reaction. It's a redox reaction. And I want to balance this redox reaction, but the condition right here now is basic, not acidic. No, it's really the same thing. There's only one difference at the very end. So let's balance this like it was acidic. Let's split this into two half reaction. So I'll have MnO4 becoming MnO2. I have on this side C2O4 becoming CO2. Okay, just like what we've done before. All right, okay, let's do this. So MnO4, MnO2 plus 2 water, because we want to balance out the oxygen first. Then let's balance out the hydrogen. Right? Now I'm gonna quickly show you. There you go. Okay. Takes 3 electrons on the left side to make sure everybody is balanced compared to the right side. Now let's do blue line. Oh, wait. I think I made a mistake here. I'm sorry. I knew something was bad. There you go. You don't have to do any work. Let's put a 2 in front of carbon dioxide and you're good. Because there's 4 oxygen. No need to insert hydrogen because there's really really don't need to. Now just make sure the charge is consistent. There you go. Okay, 2 electrons on the right side to balance out the 2 negative charge on the left. All right, now it's time to combine them. But before we combine them, we have to make sure that the 2 electron number are consistent. So we have 3 and 2. What is the lowest common multiple for 3 and 2? Well, it's 6, of course. To turn 3 to 6, you multiply by 2. So I'm going to multiply everybody here by 2. Okay? Well, to get 2 to be 6, you multiply by 3. So I'm going to multiply everybody here by 3. Okay? Now I'm going to combine them. Okay? Now, normally under acidic condition, this is where you stop. But we're not looking at acidic condition, are we? Today we're looking at basic condition. So what do we do now? Because this is in basic condition. Well, we have one more step. Well, it's two more steps actually. And this step involves hydrogen. Okay? We know that hydrogen ion is the basis of acidity. We're not at acidity. We're at basicity. So we might want to get rid of H+. Now, I have 8 H pluses. How am I going to get rid of 8 H pluses? Well, the logical thing is insert 8 OH minuses. Okay, so let's do that. We're going to insert 8 OH minuses. Now, the thing here is this. We can't just introduce OH on the left and not introduce OH on the right. So whatever you do on the left, you have to really do the same thing on the right. Okay, so there's your 8OH, 8OH. Now, take a look at this. You have 8 H plus and 8 OH minuses. H plus and OH minuses come together to form water. So what you have right here is actually 8 water. 8 water reacting with 2MnO4 plus 3 C2O4. All that will give you 8 OH minus, which is the remnants of basic condition, plus MnO2 plus water plus carbon dioxide. Now, take a look at this. We can make this a little nicer. We can get rid of the water. Get rid of the 4 water here. This 8 becomes a 4. Now this is the balanced redox reaction under basic conditions. So the extra step here is wherever you see H plus, you will try to get rid of all those H plus with OH minus. Combine that to become water like we see here, and see if there's any water that you can cancel out at the end. All right? Hopefully that helps. Now I'm going to do one more example with you, and then I'm going to call it for the day. So let's clear this page. Okay, let's do a special one. Let's do a very special one. Let's do one that looks like this. Again, under basic condition. Okay? Now the first thing you will looking at the screen or looking at whatever you're looking at, you probably have angry thoughts about, hey, how am I going to turn this to 2/2 equation? There's only one chemical on the left side, and how am I going to split this up? Well, it's actually easier than you thought. When I say split it up, I don't mean like equally split it up. In this case, OCl minus went on to become Cl minus. It's not like it's not true. OCl minus can become ClO3 minus. Oh, did I forget to put a minus sign here? Okay. There you go. See? This is also turning this reaction to 2/2 equation. It's the same idea. All right, let's quickly balance this like it was an acidic condition. All right, so 2H plus plus OCl minus will give you Cl minus and H2O. I can see those two H pluses. Something's going to happen to those guys. All right. Oh, very quickly. 2 electrons. Okay. For this side, I did not use blue. I'll add 2 H2O. Okay, 4 H's. And it seems like we're gonna add 4 electrons to the right side here. All right. Okay. Lowest common multiple, 2 and 4. 2 and 4 is 4. So we're not going to do anything to the blue line. We're going to multiply everybody by 2 on the red line. There we go. That was simple. Automatically, just get rid of these. Okay. Now, let's put it together. Let's put it together. 4H plus 2 OCl minus plus 2 water plus OCl minus. That will give you 2 chloride ion plus 2 water plus ClO3 plus 4H plus. Oh, look at that. Looks like acidic or basic, it really doesn't matter for this case, doesn't it? Hope you see that, because the H plus gets canceled. There is no need to insert OH minus. Oh, this may be a bad example, actually. So, but there are other things that you can do to this. Of course, water can go. There's no need for water to stay. And if you look closely, you can actually combine the 2 OCl minus. This becomes 2 chloride ion plus chlorate ion. Right? Now, it does seem silly that we're doing all this work to get this, because you can just balance this as is from the top. But anyway, I'm sure these steps are necessary to be shown why the balance reaction are as such. Okay. Now, I do have 3 questions for you to balance, and they're all under basic condition. So make sure you download that, or just do it through the docs that I'm going to be sending you, and hopefully you remember exactly what you need to do. And we'll take it up on Friday. Now, we have one more lesson on 9.1, which is on titration of redox reaction and the Winkler method. So we'll look at that tomorrow. All right, bye.